सादर प्रणाम। एनसीईआरटी की लिसनिंग टू लर्न सीरीज़ में आप सभी का स्वागत है। आज हम इस सीरीज़ के छठे पड़ाव पर हैं और आज हमारे साथ टी.वाई. पाटिल इंटरनेशनल यूनिवर्सिटी के वाइस चांसलर प्रोफेसर प्रभात रंजन पुणे से जुड़े हुए हैं, जो कि हमें न्यूक्लियर फ्यूज़न द ड्रीम सोर्स ऑफ एनर्जी पर आज हम सब लोगों को संबोधित करेंगे। ये प्रोग्राम एनसीईआरटी के यूट्यूब चैनल एनसीईआरटी ऑफिशियल पर लाइव है, फेसबुक एनसीईआरटी के फेसबुक लाइव सेशन पर लाइव है, इंस्टाग्राम पर लाइव है। आप सभी लोग अपने सवाल पूछ सकते हैं इस यूट्यूब चैनल के द्वारा, या आप हमें ईमेल कर सकते हैं DTH class 9, class 10, class 11, class 12 @cit.nic.in पर। हम आपके सभी प्रश्नों का इस उद्बोधन के बाद समावेशन करने का पूरा प्रयास करेंगे। इस प्रोग्राम को शुरू करते समय मैं आप सबको इंट्रोड्यूस कराना चाहूँगा। जो हम एनसीईआरटी स्टूडियोज़ में लोग हैं और मेरे साथ में बैठे हैं प्रोफेसर श्रीधर श्रीवास्तव, जो कि एनसीईआरटी के डायरेक्टर हैं, और आज हमें उनका भी उद्बोधन सुनने को मिलेगा, जो कि इस वेबिनार सीरीज़ के बारे में हम सभी लोगों को बताएंगे। उनके साथ में डॉक्टर सुनीता फरकिया, शी इज़ द हेड ऑफ द डिपार्टमेंट ऑफ एजुकेशन इन साइंस एंड मैथमेटिक्स एट एनसीईआरटी। दिस इज द डिपार्टमेंट which organizes all these webinar series together with other NCERT programs in science and mathematics education. Now I welcome Dr. Sridhar Srivastava to this program and request him to welcome Professor Ranjan to the audience and introduce this program. Please.
आप सभी को पुनः नमस्कार। आप सभी का इस कार्यक्रम में स्वागत है। डॉक्टर प्रभात रंजन जी जो हमारे साथ जुड़े हुए हैं टी.वाई. पाटिल यूनिवर्सिटी पुणे से, इंटरनेशनल यूनिवर्सिटी पुणे से, और इस प्रोग्राम में जो हमारे साथी ने अभी बताया कि जो लाइव है, इस पे हमारी अपेक्षा है कि छात्र भी हमसे जुड़े हुए हैं। आप सभी को पता है कि एनसीईआरटी एक ऐसी संस्थान है जो पिछले 6 दशकों से इस देश में स्कूली शिक्षा के लिए कार्य कर रही है, और स्कूली शिक्षा के विभिन्न आयामों में, जिसमें कि साइंस एजुकेशन भी एक आयाम है, उसके लिए कार्य कर रही है। और यहाँ पे विज्ञान के प्रचार प्रसार और विज्ञान के बदलते हुए स्वरूपों के बारे में भी यह विचार करती है। और इसमें हमारे साथ, जैसे कि आज हमारे साथ डॉक्टर प्रभात रंजन जुड़े हैं, वैसे विभिन्न संस्थानों से हमारे जो साइंटिस्ट, टीचर्स और डिफरेंट स्टेक होल्डर्स हमसे जुड़ते हैं। विगत साल आपने जो देखा, द लास्ट ईयर 2020 वी विटनेस्ड पैंडेमिक, and you all know that unfortunately this year also we saw the second wave, and this situation has given us many learnings. Children are also there and they will share the same thought with me, that this pandemic has given us to learn new things, to new situation, to witness new situation, and to be more careful about ourselves and our surroundings. In the same way, if I mention this webinar, the word that came before us, which is a real-time transmission or interaction by leveraging the ICT technology. In the area of knowledge transmission or discussion, NCERT has been using, and schools all across the country and the world have been using this medium. And this webinar has given us a strength, an opportunity to make our interaction more frequent, keeping ourselves safe health-wise, and also to disseminate this interaction across the country and the world at the same time, in the real time. So today we are also utilizing this opportunity, and we are here for this webinar. In recent time, NCERT has utilized the contribution, and I am very thankful to them, the Indian diaspora which is there around the world, and we conducted a series in which 5 lecture series, and this we are terming this series is listening to learn, and it is very important for young children of different stages in the school education, but more for the secondary stage students to listen to the researches or to the discourses of scientists, teachers, professors, and to see what science can play the role in the life of this whole planet and thereby in the life of the humankind. So in the same series, today we are here for this webinar, and I am again very thankful to Professor Prabhat Ranjan, and sir, I welcome you with folded hands on behalf of the institution.
Thank you so much.
And sir, this webinar, what we are there to listen to you, sir. About that I would speak very less, because I don't want to be there between you and the listeners. Let me just say that India is a part of international thermonuclear experimental reactor ITER program, and it is an experimental fusion reactor based on tokamak concept of magnetic configuration to create and maintain the condition for controlled fusion reactions. So surely, as we know that in country our energy need is changing, and we are a big population, we are the largest democracy, and we have yet to reach to the development goal that we are, we are celebrating Bharat ka Azadi ka Amrit Mahotsav, and we have entered the 75th year of our independence, and we are celebrating it. And if we keep the target of coming years and decades, 2-3 decades, yet India has to realize the ultimate of the development in several fields. So here energy need would be there, and how this fusion technique or technology can help in that, in realizing that goal. For that we are here to listen to Professor Prabhat Ranjan. Sir, with this I welcome you again, and I thank you all listeners and others who are connected to this program. Thank you.
So thank you very much, Dr. Srivastava, for introducing this program, introducing the series once again. Now I request Professor Sarita Farakia, the head Department of Education in Science and Mathematics at NCERT, to kindly introduce the speaker to our audience. Please.
Good morning and warm welcome to this Listening to Learn series of NCERT. I am feeling so honored to introduce today's speaker, renowned nuclear fusion scientist, a futurist, an educator, an innovator, an entrepreneur, and a science communicator, Dr. Prabhat Ranjan, who is now Vice Chancellor in D.Y. Patil International University. From 2013 to 18, he was heading India's technology think tank, Technology Information Forecasting and Assessment Council in Delhi as its executive director. TIFSC is an autonomous body of Department of Science and Technology, Government of India. IFSC developed technology vision in 2035 during his tenure. Earlier he worked for nearly 20 years, making important contributions to nuclear fusion research as a scientist in India as well as in USA. After this, he worked on Chandrayaan second mission, wildlife, agriculture and brain-computer interface. He has brought smile on faces of many people with severe disability by innovative assistive technology for more than 11 years. List of his achievements and contributions to global science and technology is endless. He has many awards in his credit. He was educated in Netarhat School near Ranchi and IIT Kharagpur. He is a product of IIT Kharagpur and Delhi University. He received his PhD from University of California, Berkeley, where he carried out his research on nuclear fusion at Lawrence Berkeley Laboratory during 1983 to 86. He immediately returned to India after this and carried out research in nuclear fusion area at Saha Institute of Nuclear Physics, Calcutta, and Institute for Plasma Research, IPR, Gandhinagar. So, may I request Professor Prabhat Ranjan to bless us with his valuable speech to our viewers and us. Thank you so much, sir. Please, sir.
Thank you, Dr. Sunita and Dr. Srivastav. With NCERT, I have a long relationship. In 1976, I had received the National Science Talent Search Award through NCERT when I was in school. And then from 2013 to 2018, I was in TIFAC. I was introduced, and I used to every single day, morning, evening, I used to cross the gate number 2 of NCERT. So thank you very much for giving me this opportunity. The topic as has been given is nuclear fusion, dream source of energy. My blog site is ranjan.in. This site I will be referring to a few times. So those who are interested can visit this site for more information. And as this lecture is a series of 2 lectures, so today and next Friday, 10th and 17th, I will be covering some part today and some part next Friday. Today is auspicious occasion of the Ganesh Chaturthi, and Maharashtra is being celebrated with great fervor. And I can hear drum sounds all over the country, all over my society. And it's a very auspicious occasion to talk about this. It's not really auspicious occasion because of Ganesh Chaturthi, but there are other regions also that I'll be covering. For example, in news media over last few months, you have been seeing a lot of articles like this. China's artificial sun sets world record achieves plasma temperature of 120 million degrees centigrade. And actually, if you see in the footnote saying 120 million Celsius for 101 seconds and 160 million for 20 seconds. 160 million means 16 crore degrees centigrade temperature. The temperature of the sun is about maximum temperature inside the sun is about 1.5 to 1.6 crore. So we achieved more than 10 times that is what is there inside the core of the sun. What you see from surface is only 6,000 to 7,000 degrees centigrade. The core of the sun, which is very, very hot, and we have created on Earth even much, much hotter temperatures than inside the sun. It's unimaginable. Similarly, there's one more news that came just last 10 days or so that says National Ignition Facility achieves breakthrough in laser fusion. There's one more news that just came just 2-3 days ago that says Commonwealth fusion system creates viable path to commercial fusion power with the world's strongest magnet, 20 Tesla. You can see this. Actually, this is using high temperature superconducting magnets. All of these are leading to tell us that there is something happening and we may be able to achieve nuclear fusion much faster than expected. And I will cover this part as well. So to give a little outline of this, just for viewers, I will talk about what is fusion or nuclear fusion. I'll be using the term fusion to mean nuclear fusion here. Why do we need fusion? What are the different approaches to achieve fusion? What is the magnetic confinement method? There are different methods of doing this. 2 are popular: magnetic confinement and inertial confinement. And then I will talk about work in India for last almost 4 decades and the progress and the current status. And there are certain advanced topics and more details that we'll be covering the next lecture next Friday. For viewers, we have heard from in our mythology that Hanumanji actually was playing around and he saw sun and he thought it's a ball that he can play with and he captured that. Actually, as a nuclear fusion scientist, our task is to become like Hanumanji and capture sun and put it into a box. So a scientist said that we say we want to put the sun into a box. The idea is great. The problem is that we don't know how to build the box. So this is what we scientists have been trying for more than 70 years to try to build this box where we can capture the sun. And as I mentioned, that we have been able to create temperatures which are even 10 times more than that of the sun, 16 crore degrees centigrade, 160 million degrees centigrade. Just recently in China, it has been achieved last a few weeks. The year 1920, 101 years ago, was a very, very important year. There were 2 important things that happened. Most of you would have heard Dr. Meghnad Saha. He gave a Saha annihilation equation that is considered to start the plasma physics. So the way we create nuclear fusion, we heat it up to such temperature that the 3 states of matter that we hear about, solid, liquid, and gas, actually it goes into plasma state. And so we, as a nuclear fusion scientists, we are also called plasma physicists. For example, the main nuclear fusion center of the research in the country is Institute for Plasma Research, where I was there from 1995 to 2002 as project leader of reactors. So Saha-Anderson equation plays a very important role in the start of plasma physics. And in the same year, Arthur Eddington said that nuclear fusion processes take place inside the stars. So what we see, solid, liquid, and gas on Earth that we talk about, we learn them in our physics courses, is actually only 1% of the matter in the universe. 99% of the matter in the universe is in plasma state. It includes sun, stars. And so we don't hear about that because we don't see it in real life. So plasma is also considered as a fourth state of matter loosely. So on the occasion of 100 years of this Saha-Anderson equation, Arthur Eddington, on December 3, 2002, I announced first time in the country a project called Project Sunland, funded by private investment, which I'm mentoring. I'm the chief mentor of the Project Sunland, which we have started nucleating in my university. We had said that in early 2021 we'll start this. So on the occasion of 100 years of this, we announced this. I'll talk about it a little bit later and also in next talk. So it's a very important time. What is nuclear fusion? So we hear about nuclear bombs, atomic bombs and so on, or atomic power stations. There actually fission process takes place where you break nuclei into smaller fragments. Fusion is the reverse. We try to combine, we try to unite light atoms to form heavier atoms. So fusion is the process of light atoms uniting to form heavier atoms. In this process, it releases energy. That is the energy that is of our interest, but I must also tell you one more thing. In addition to energy, it also releases neutrons. And neutrons can also be of our interest. I'll talk about that later on. Now, the nuclei are positively charged. So when you try to fuse them together, you to bring them closer together, they try to repel each other. As you have learned that the nuclei or any charged particle which are of same charge, say positive or negative, they will repel each other. To try to overcome that positively charged thing, they are repelling each other, we have to apply tremendous force. So it is not very easy to do that. If I put a negative charge and positive charge, they will attract each other. When I put two positive or two negative, it's going to be very, very tough. And that's why this problem of nuclear fusion is very, very tough. And that's why we need to go to such higher temperatures of 10 to 20 crore degrees centigrade, 100 to 200 million degrees centigrade. And there are other ways of doing this also. If I compare nuclear fusion and fission, in the fission we gain energy by splitting apart heavier atoms, for example, uranium, into small atoms. I would like to use two terms here. One is group of materials is called fissile material, and other is called fertile materials. So uranium-235 is a naturally occurring fissile material, which is about 0.7%. Only 0.7% of naturally occurring uranium is uranium-235. That is used in our atomic power stations. There are other materials like plutonium-239 and uranium-233. These are not available naturally. They're artificially produced from these fertile materials like uranium-238 and thorium-232. So actually, fertile materials, they are not itself capable of undergoing fission with low energy neutrons, but actually they can capture neutrons after absorption of that and then convert themselves into fissile materials. So uranium-238 and thorium-232 are naturally occurring fertile materials. By absorbing neutrons, they can be converted into fissile materials like plutonium-239 and uranium-233. India has about 25% reserve of thorium of the world within India, and scientists have been trying to convert this usefully into uranium-233 to convert into fissile material and produce power. I'll come back to this point also. We are also trying to do this. So as I mentioned, fusion is combining light atoms to form heavier ones. For example, you can convert hydrogen isotopes like deuterium and tritium, and this will lead to helium. So something is very, very funny here. We are talking about that when you break atoms in fission or break nuclei through fission process, it releases energy. At the same time, we are also saying that when you combine light atoms,
म्यूटेड हो गया
No, there's some connection. Internet की problem है. Dr. Ranjan, just there is some problem, it seems, in the internet network problem. Let us try to reconnect it.
Or
Let me request my producer here to kindly reconnect it. In the meantime, yes, see, India's nuclear fusion program, children, the nuclear fission and fusion, these are the two basic nuclear processes which we are acquainted. Fission means जब कोई बड़ा एक एटम होता है, उस बड़े एटम को छोटे हिस्से में टूटता है, जब छोटे हिस्से में टूटता है तो उसमें से कुछ एनर्जी रिलीज होती है। वो एनर्जी कहाँ से रिलीज होती है कि दो अलग अलग जो छोटे फ्रेगमेंट्स बने हैं